Hey and welcome to the second part of the Camunda 8 Code Studio series. As mentioned before, we are now going to start with the hands-on part, so that's why I have already opened up GitHub, so we can together take a look on the repository. Once again, you can find all the necessary links in the video description down below, so we can both work together on this kind of task we do have right here. So let's go down, let's take a look on how this course is structured and what we'll do in this kind of episode. And as you can see, the first exercise right here is all about what kind of process can you imagine to make your government more efficient in processing HZV cases. Design it. So let's go down. There's exercise 1. We can take a more in-depth look in here. And it gives us like a scenario, and it tells us, hey, please use the Camunda Web Modeler in order to design this. And down below there are some solutions, and if you do not have any clue, you can check out the documentations for BPMN as well as the decision model and notation for Camunda 8. But to set you up, let's first of all go to the Web Modeler and quickly talk about how you can set up your trial for Camunda Platform 8, because that's now necessary. To do so, let's switch tabs right here. We go to camunda.com, get-started. There you can already see either you can choose to go for Camunda Platform 8 SaaS or the self-managed one, but for our purposes, the SaaS offering is the better one because it does contain our web modeler. So we can continue to SaaS, and then we get to the registration side for the 30-day trial. And there you can simply fill out all your information to create the account. And once you have done this, you are redirected to the so-called Camunda Cloud Console. And that's kind of your entry point to the Camunda Platform 8 SaaS offering. In here, you might already see there is this modeler button on top, and that's where we need to click on in order to start modeling. We take a look on the rest of this console and all the other products which are included in the next video. So for today, I really want to focus on the modeler experience. So let's do so, click on there, and then we get redirected to our modeler, and there you can already see I've created multiple projects. You can do so via here, and in this project I do have simply some BPMN diagrams as well as DMN diagrams and forms. For our purposes, we do now want to use or to design a BPM diagram, and I will show you now how you can get started with it. So first of all, click on new. You can decide what you want to do. You could also upload files from your computer. So to get started with, let's go with a new BPMN diagram. You can choose from some templates to get a better feeling about how you can model with BPMN and how some processes might look like. But for our purposes, let's create a blank one, and we'll call this HZV process refined. Great. So as you do see, we do have a little start event here, and now I do have the possibility to simply append another kind of task or another kind of activity, and that's what we are also going to start with. So maybe let's go for this kind of task. I can use, or this kind of activity, I can use this little wrench here in order to change the type, for instance, to a send task, and then I can continue myself clicking through these events, for instance using service task, so on and so forth, until at some point in time, let's go with the connector, REST connector, the process ends. So that's kind of the end event. All my activities can be now surrounded with a process pool, which simply signalizes the context of my process. And we are going to call this one now HZV process. So to really get now started with modeling, we would need to check out this kind of description, the scenario description in our README. that's what we are going to do later, because first of all, I still want to set you up with the modeler tool and what the tool provides. As you do have seen, modeling is pretty easy. I can drag and drop elements. I do have some more tools on my bar at the left side. And yeah, for instance, I can now give things a name. For instance, send a message, so people are aware of what these tasks do. So on and so forth. On the right side, you can see the property panel. So for instance, when selecting our send task, I do have the possibility right here to set them properties. For instance, the name, the activity ID, I can add some documentation, I can add the task definition where I then define the kind of service fetching the message and trying to send it out. I can set inputs, outputs, headers, so on and so forth. So there's the possibility to really configure these activities. On the other side, I do have comments, and that's a pretty nice feature since we are in the SaaS world right here. But now, for instance, if someone has been added, could tag him with an @ sign and then ask him, for instance, what should I do here? Is this correct? And then someone else could respond to that. Another powerful feature of the modeler, and a thing I do recommend to use, is the so-called milestone history. So let's imagine you work collaboratively on a process model, or you have multiple versions of your process. You want to use this little button in order to access your milestone history. And there you could then say, hey, let's create a new milestone. Let's say initial version, create. And in case somebody else would mess up the whole diagram, for instance, by deleting it and doing something new, we always have the possibility to go back into the milestone history, take a look on what has changed, basically everything, and restore our deleted model. And that's great. So in case something goes wrong, that's also always a good fallback. And in hands-on workshops, we actually try to use this feature, because working collaboratively on diagrams, for instance, person A has created a process and then I'm joining, giving him advice, drawing something here and there, then he always has the possibility to revert back and do it by themselves or by themselves again, which is a great feature, especially for training purposes. But now let's concentrate on our HZV process use case. So just to describe the scenario to you, we are designing a process to manage the quarantine of persons infected with the hypothetical zombie virus. In total, statistically, 5% of the people who are infected with the zombie virus turn into actually undead zombies with an unstable carving to eat human brains. That's bad. We for sure don't want this to happen, or we don't want this to happen with the whole world. So for sure we need to set up this quarantine. The other 95% experience rather mild symptoms and do have an extreme carving for ice cream. So that's good for the ice cream industry. So instead of buying toilet paper and getting all the other things like oil, so on and so forth, ice cream will be sold out like always. Better than toilet paper, at least from what I can say. So let's go on. In order to stop the spread of the undead and the collapse of the modern civilization, we need to design and automate the quarantine process using Camunda Platform 8. So far, so good. So the virus has a different effect on different age groups, similar to COVID as we do know now. People aged 30 and under recover faster, and they can be cleared of the damage of turning into zombies in 5 to 7 days, whereas people over 30 can turn into zombies anywhere up to 10 days. Nevertheless, in order to keep society running, it's an acceptable risk to release people under 31 years of age from quarantine at a lower bound of their risk period, so like 5 days, if they work in a critical infrastructure. So that's pretty important. So whenever there's, for instance, someone working in a power plant, he's under 31 years old, he can get out of the quarantine after 5 days. And that's very important to just keep the site running. The same applies to nurses, to police officers, so on and so forth. So everyone in the critical infrastructure is captured there. So we need to balance the collapse of the civilization from brain-eating zombies or a collapse from a runaway nuclear power plant here. When someone tests positive for the HZV, the health department, so we do usually get informed, and now we want to immediately contact the infected person and notify them to quarantine. As you do remember, like when I got COVID, nobody from the government cared. I didn't receive anything. So we don't want this to happen again. We really want to make sure that the person infected with HZV stays at home and is aware of this right away. And then we do need to check regularly on them. So we want to check whether they are already like undead or whether they are still humans and only want to eat some ice cream. And therefore, as said, checking every 2 days on them. So if the quarantine process ends, there's going to be another one started, which then handles kind of, or putting it in another phrase, if the person has turned into a zombie and the quarantine has ended or not ended, we are going to trigger just another process which then takes care of what to do with an undead zombie. When the quarantine period ends without the person turning into a zombie, we want to issue some digital recovery certificates and send them to the person. And with these certificates, they are very beneficial since you might have had this carving for ice cream and then you get a 10% discount at participating ice cream retailers. So that's a huge benefit once you are healthy again. Maybe you don't have that extreme carving of ice cream anymore, but still 10% better than nothing, at least something. So with all these informations, we can now go to Camunda's Web Modeler in order to design the process. And need a hint? There's the solution down here, take a look at it. But otherwise, now is the time to pause this video because you are going to model it by yourself and then we are comparing our solutions. Let's see whether we do have a similar one or whether you do have completely different idea. And feel free to share those diagrams you've created, even though we are now in this kind of asynchronous video format. Please share them. That's for sure very interesting, even for me. So I'm looking forward to your submissions about the HZV process. Welcome back. Hopefully you have enjoyed designing the process with BPMN and DMN. I'm now going to introduce you my kind of suggestion how to deal with something like this process. But of course, your solution could look totally different and still be valid. Keep that in mind. So my decision was to have, of course, the start of the process linked to the positive HZV test. So now the person has provenly got the Hypothetical Zombie Virus. And first of all, what we are going to do is to run a DMN table in order to check how long does the person need to stay in quarantine. We are going to check out this table later on after we have covered the whole process. I think that's way more beneficial. After having calculated that time period, so you can imagine like having a variable then which decides at what time the person can then leave the quarantine. And before going into quarantine, we of course want to notify the person. So there is a service task. It could also be like a send task, sending out the message, or we could also make use of a connector. So for instance, there is a email template or email connector with SendGrid. So we could use that. That would totally be valid as well. For sure, that would be interesting to try out, but let's stick to the send task for now. After having done so basically that's happening fully automated, we are going to the in quarantine sub-process. So we decided to really capture the quarantine in another separate sub-process models. And there we are going to check on the infected person first of all. So as soon as we are arrived in this quarantine process, the clerk from the health department will get a task to check on person XY in order to see if they are still healthy or are still human, or if they have turned into a zombie. So what has happened if everything goes well? So the happy path obviously is the person stays healthy, then we're going to wait for 2 days, the person will check again, and this is kind of an endless loop until we have reached like this timer boundary event. And this timer boundary event contains the variable which we have decided on in this DMN task. In this business rule task. So that's kind of the quarantine period, and after we have reached that time, we are going to just end the SOAP process and continue to generate the certificate of recovery, to send it out, and then our process ends. So what's going to happen if the person has turned into a zombie? And as mentioned, the sub-process is immediately going to end, and we are going to continue to this end event. So we do have a zombie, and then we could also trigger another process which then takes care of what do we do with zombies. But yeah, let's not talk about it. Let's stay positive that hopefully like most of the people will then turn out healthy. So that's kind of the process we have come up with. And now let me show you the decision which is relevant for determining the length of quarantine. So I've got here the DMN diagram. I will open it, and there you can see it's like a DRD, decision requirements diagram, where we do have our decision, and I do wanted to visualize like those two variables down here which are relevant for making the decision. As you can have read from the text, it's first of all the age as well as the employment category. Taking a look into the actual decision, we do have like these two input parameters visualized in year, and depending on them, we then decide for the quarantine duration. So, for instance, if somebody works in the critical infrastructure but is above 30 years old, he's still going to be quarantined for 10 days. But if he is working in a critical infrastructure and is under 30 years or under 31 years, he only needs to stay in quarantine for 5 days. And the same applies to when he is in a non-critical infrastructure. We just have those 2 days extra. So the person under 31 years is going to be out after 7 days of quarantine. And that's the only thing which we do here. And yeah, we are then going to pass this output parameter right here, the name or the output variable with the name quarantine duration, back to our process model, and just going back one more time to our model, this one right here, and we are going to pass this variable into this timer event. So as you can see, the timer duration equals our quarantine duration. That parameter, that variable, we are going to retrieve from the business rule task. So awesome, that's what our process looks like, and we are going to take a more in-depth look on all the technical properties set in there later on in our next, maybe the one afterwards, let's see. We are definitely going to talk about technical properties which are set in that diagram later on. Thanks for listening, and tune in at the next episode. Thanks for watching, see you soon.